Hi guys, you're welcome back. This is the first module creating the Android layout of this particular application. We'll be moving straight to Android Studio where I have the source file, which is the basic structure of how this application is actually going to look like. We have the Gradle scripts, which is the build Gradle, module, and the project session. I'll take you through the module app session. I'm actually using Android Studio 2.2.3, which is the latest version at the time of recording of this tutorial. We implore you to upgrade your Android Studio. Probably you're still using the 1.5 or the version 1 series. I would like you to upgrade to at least to the 2. Version of Android Studio so that you're going to actually use almost all the functionality in this particular tutorial. Right there in the dependencies, I have the Android test compiler, which is the support annotation, the test runner, the rules 0.5. These are all instrumentation dependencies that we're going to use in the course of this application. We have the app compat, which is version 7, 25.0.1. The application ID, you should be familiar with this interface. So let's get to look at the project session using the 2.3.0 Alpha 1 build tools. From here, I'll be moving to the rest. The layout files of this application. We have the activity forecast. This is the rendering library of this particular application, the UI. So we actually have it as a frame layout, if you can see from this UI screen. That's the weather app, and it's a frame layout. Let's get to look at the text, which is actually holding on to the XML files of this particular UI. This is a frame layout with a layout with an height match parent, and it has a scroll view. You know, this is the wrap, the text view in a scroll view, and it set the scroll view width to the match parent and the height to the wrap content, just like what you've seen right here. And you have the text view that is actually going to change. You need to change the advert ID attributes. You know, we assign TV weather data, and you give the text view to actually have 16 dp and of padding of 16 dp. You set the text size to 20 sp, and you remove all attributes with the word constraint in them, and you remove the default text from the text view. That's what this is actually doing. The text view sitting right inside the scroll view and right inside the frame layout. So this is the layouts that we'll be using going further, developing more on these in subsequent tutorials. Let's get to look at the values. We have the strings, you know, very important. Well, we're going to be using different string values. We have the weather app, which is the app name. We have the labeling to the forecast. We have for the tomorrow. We have for the date format. You know, this is actually for the date format. And we have temperature format in Celsius. This is the format in Celsius. We also have the format in Fahrenheit, and we have the wind in kilo per hour, and we have also the wind in the MPH format. And we have the weather conditions from the open weather map. That's where we're actually going to get most of our data from. The storm, the drizzle, the light rain, moderate rain, heavy rain, intense, extreme freezing, light shower, heavy shower, ragged shower, the light snow, snow itself, the heavy snow, sleet, the shower sleet, the rain and snow, the shower and snow. We have the mist, the smoke, the haze, the sand, the fog, the sand, the dust, the volcanic ash, the squares, the tornado, the clear, the mostly clear, the scattered clouds, the broken cloud, the overcast cloud. We have the hurricane, the cold, the hot, the windy, and a lot of them right there. So these are all different conditions that we actually get from the open weather map. We'll be looking at the styles. You know, this is just the default style that's been created, the dark action bar, and also the colors. You know, we use the color primary, which is blue, the darker blue, and the color accent. And let's get to look at the drawables. We have some drawable files we use here. We have the art clear XML. You know, these are all vector shapes. We have for the clouds. We have for the fog. We have for the light clouds, the light rain, the snow, and for the storm, we have the clear PNG. You know, this is actually a sort of rainbow or a sort of sunshine logo. We have the cloudy PNG, we have the fog, we have the light clouds, we have the light rain, the snow, and the storm PNGs. Let's get to look at the Java classes. Now we have the sub packages, which is the data and the utilities. These are just the MVC approach to Android development, whereby you don't just model all classes in just one way. You need to place them in different sub packages so that it will be called appropriately. So if there is one changes, you just have to effect it in just one, and it's going to actually affect the other. That's the essence of the MVC approach. So we have the main activity of this particular application. This extends AppCompat. Just have the onCreate, because this actually the creating layout tutorial. We're still going to code a lot of things right inside these methods. We have the set content view to the activity forecast we just talked about. Let's get to look at the utilities. We have the network utils, the open weather JSON utils, the weather date utils, and the weather utilities. Let's get to look at the network utilities. This is you can see, if you notice, we have the final string, the dynamic weather URI. This is actually calling a JSON weather URI, which is actually gotten from the openweather.org. We also have a static weather, also a JSON file from the openweather.org. We have the forecast-based URL, which is called static weather URI. We have the format that we're going to use the API to return, which is JSON. And we have the units that the API is going to return, which is metric units. And the number of days we want the API to return, which is 14. We have the query parameters. We have the latitude param, the longitude, which is lat and long. We have the format param, which is mode, the unit param, which is units, and the days parameter, which is CNT. Also the build URL, which is actually returning null. If you notice, most of these methods are empty. They were actually going to be adding all stuff into these methods. Now, this will be implemented in future lessons. As I actually comment this out, that this will be implemented in future lessons. We have the get response from HTTP URL. This is actually the HTTP call, whereby we instantiate the HTTP URL connection class, creating an object called URL connection, and having a try and catch input stream to get the input stream method. And there's a scanner. The new scanner is being created, whereby we use the delimiter, which is the backward slash. We have the base input, which is a boolean, and have the scanner as next, and the as input is be passed as a parameter to test. So if this actually returns, it's going to return the next scanner, that the scanner input. Else it's going to return null. And we have the finally the URL connection is going to disconnect. We're actually going to be coding more on this in subsequent lessons. We have the open weather JSON utilities. This is actually holding on a string, whereby we get a simple weather string from JSON. This is when we actually encode JSON, which shows a JSON exception. The weather information for each day forecast info is an element of the list array. We have the list, and all temperature are children of the temperature object. Get to understand that. We have the maximum temperature for the day and the minimum. We have the weather and the description. We also have the message code that we got. We have the string array to hold each day's weather string, which is the past weather data. Is null for now. We have the forecast JSON, whereby we instantiate the new JSON object and pass the forecast JSON string as its parameter. So if there's an error, the forecast JSON is going to get the integer, and we have the error code, which is actually a parameter to the switch case. So the first case is the HTTP URL connection. If it's okay, it's going to break. And if it's not found, we're actually going to still add up to all this. We have the weather array, whereby we forecast the JSON. We get the JSON array from the URI gotten, which is the OWM list, and the past weather data as well, the weather array length. We have the local data date, we have the UTC date, and the start date. These are all weather date utilities. We get to look at the weather date utilities class over there. So we have a for loop to actually iterate through the weather array length, whereby we get the date, the high, and the low. These are the values that will be collected. We're going to collect the date, time in milliseconds, the high, the low, and the string description. We're also going to get the JSON object representing the day. How about the day forecast? We ignore the daytime values embedded in the JSON and assume that the values are returned in order by day. Whereby we have the weather date utilities, and we have the description in the child array called the weather. This is the weather object, which is the first element long. That element also contains a weather code. All right, that's fine. We'll get to talk about these later on. Let's get to look at the weather date utilities. This is where we have the second in millis, the minutes, the hour, and the day. We have the get day number, where we have the time zone, where we get the default time zone. We have the normalize date. We have the get local date format from UTC. This is the UTC format of date. We have from the local, we have the get friendly date string method, whereby we pass the context, the date in milliseconds, and the show full date are all parameters passed into this particular method. Now we call the local date, which is actually the day number, the current day number. We get the local date from the UTC, pass the values, the local date, and the current time in milliseconds. That's cool. Let's get to look at the weather utilities. This is actually the weather utilities, whereby we have the string, the log tag. We have the Celsius to Fahrenheit, while we're going to convert all this. We have the double temperature in Celsius as the parameter, whereby we have the Fahrenheit. There's a calculation whereby you convert Celsius to Fahrenheit. So you need to multiply by 1.8 and add by 32. So from there you get the Fahrenheit value. We have the format temperature, where we get the context and the temperature itself as parameters. We have the high and lows, which is a math to round up to the high and the round up to the low. These are all math metrics. We have the get formatted wind. This is for the wind. So the wind format, it's a calculation for the wind format, which is actually been done. And where what's fun, writing really long if-else statements with tons of possible conditions, so you can seriously try it out. This if the degrees is greater than 337.5 or degrees is less than 22.5, the direction should be north. For the northeast, for the east, southeast, south, southwest, west, and northwest. So these are all calculations that were done to get the right wind direction. Let's get the string for weather condition. So for us to know the night rain, pass the weather ID as the parameter. So there's a case for 500 will be the light rain, 501 will be moderate rain, 502 will be heavy rain. These are all from the string XML. 503 will be intense, so on. So it gets down, to the Nexus 2, which is for hurricane. Also for the static integer, we get the icon resource for weather condition. Pass the weather ID to as this parameter. So there's also a long if statement here. So if the weather ID is greater than 200 and the weather ID is less than or equals to 232, it's actually greater than or equals to 200, the drawable will be storm. This is actually just going to tweak up the drawables. The icons being called for the light rain, for the rain, snow, rain, fog, storm, and so We also have the last one, which is the get at resource for weather condition. For the art storm, the light rain, the art snow, the art rain, fog storm. There's an if else statement to test to actually know which particular art research to pick for the particular call. So that's just that for the utilities. We have for the data, whereby we have the weather preferences. That's for the settings. So now we have the ability to set the preference city name and also the coordinates, which is the coordinate lat and the longitude. We're going to be using the Mountain View, California, which is the Amplifex location of Google, which is for Googleplex. This is actually situated in USA. And we have the weather coordinates, for the two. This is the lat and the longitude coordinates. So that's just what that's doing. We get to add more to these in subsequent tutorial. Let's get to look at our manifest. Our manifest should just do the simple manifest we used to know, which is just the launcher activity and nothing else. We're still going to add more to these in some subsequent tutorial. So stay tuned and don't go away. The second package or the second module is right there coming.